Quadratic relations can be represented in three different forms. We have standard form, like this first one. We have factored form, which we have already seen, and we have vertex form right over here. So first thing, just by looking at them, what are the distinguishing features of each form? So just brainstorm and make a note in the chart, and then come back to the video. All right, so hopefully you made similar observations. So for standard form, we have no brackets, and it looks like whatever our expression may have been has been expanded. For factored form, you have brackets. Sometimes it's 2 brackets, sometimes there's a greatest common factor. It depends on the method that had been used. And finally, vertex form is the most new one. We have a bracket that has been raised to the power of 2. And for the most part, there will be a constant outside the bracket that is being added or subtracted. So let's see how we can use these 3 forms to pull out some key properties about parabolas. So here I have 3 different parabolas. So let's look at the first one. This parabola here can be represented by all 3 of these different equations. So we're going to start off with writing down our key properties using the graph. And then we're going to start making some observations and checking to see, can you find the vertex in one of those forms, or the zeros, or the axis of symmetry? So let's get started. The direction of opening for this first parabola is up. The y-intercept is right here. It is at 0, -8. The zeros are at -2 and 4. So it's -2, 0 and 4, 0. The vertex is the tip of the parabola, and this one is located at 1, -9. The axis of symmetry is the line that cuts the parabola in half, and it is a vertical line, so its equation is x equals, and x equals 1. The optimal value is your max or your min value, and it is where the vertex is located. The lowest point on this parabola is at -9. And like I said, it is the lowest point, so that is a minimum. And then I have the step pattern. So for the step pattern, this is a little newer. We're going to go to the vertex, and you're just going to move to the right 1 each time, and then check to see how much you're going up or down. So here, I'm going to the right 1, and then I go up 1 to get to this new point. So I'm going to write 1. I go to the right 1, and now 1, 2, 3 to get to my parabola. Then I go to the right 1, 1, 2, 3, 4, 5 to get to my key point. So this step pattern is 1, 3, 5, and it continues, but it goes off the page. So now maybe you want to start making some observations. My y-intercept is -8. Maybe you already see it in one of these forms. Your zeros are -2 and 4. Your vertex is 1, -9. Maybe you're starting to see some connections with some of these forms, but we'll solidify those once you try 2 more examples. So I want you to write down the properties for the next 2 parabolas, but I am going to go over the step pattern one more time before you pause this video. So I'm going to do the step pattern for the second parabola. So I'm going to go to my vertex, and I do want to notice that my scale is actually going up by 2, so I need to be cautious of that. So I'm going to go to the right 1, and then I go up 1 square, but that's actually worth 2 units. So 2. I go to the right 1, and now I'm going up 2, 4, 6. I go to the right 1, 2, 4, 6, 8, 10. And let's see if I can fit another one. To the right 1, 2, 4, 6, 8, 10, 12, 14. And there's the step pattern for this parabola. Now I want you to pause the video here and fill in the rest of your chart with all of the properties for the second and the third parabola. Okay, so for the second parabola, I filled in the information. Our parabola opens up. Our y-intercept is at 14. Our zeros are 1 and 7. The vertex is 4, comma, negative 18. The axis of symmetry, I hope you wrote it as an equation, x equals 4 for that line. It is a minimum of negative 18. Now I'm going to do that last one with you. So our direction of opening is down this time. The y-intercept is at negative 36. The zeros are at negative 6 and negative 2. And I am writing them as coordinates. My vertex is at negative 4, comma, 12. My axis of symmetry cuts this parabola in half, and it's going through negative 4, so x equals negative 4. The optimal value is 12 because that's as high as our parabola goes, and it is a maximum. Now let's see how you did with the step pattern. So from this vertex, which is at 12, and I want you to be careful with our scale, because if you look at our scale, each box is going up by 3. So I'm going to go to the right one, and I'm going down one box, and one box is 3 units. Now, the fact that I'm going down, my step pattern will be negative 3. Now, I go to the right one, I'm going down 3, 6, 9, negative 9. I go to the right one, and I'm going down 3, 6, 9, 12, 15. That's negative 15. And let's see if we can fit one more. To the right one, down 3, 6, 9, 12, 15, 18, 21. Or you could have just counted the squares and multiplied by 3 instead of just going up by 3s. And there we are. Now, let's see if we can make some observations. I want you to pause the video and see if you see any connections right now. I want you to mainly pay attention to the y-intercept, the zeros, and the vertex. That's my main concern right now. And then try to see if you notice anything about the direction of opening and any of the values in your table and your step pattern. So pause the video and make some observations. And if you'd like, you can go on the chart below and start filling in what you noticed. All right, so for the observations, I have done some color coding here. So I'm going to start with the y-intercept. If you look at your y-intercept values, you will notice that they are the exact same value as the constant in standard form. So here, negative 8 is the negative 8 at the end. Here the constant is 14, and so is the y-intercept. Here the constant is negative 36, and so is the y-intercept. So I'm going to go down to our chart, and I'm going to write down that observation. From standard form only, the y-intercept is c. So this constant at the end. So if you see a parabola in standard form, you'll know its y-intercept right away. Next, let's go to the zeros. So if you look at all of these zeros, I have highlighted your factored form, and you will notice that the numbers in the factored form and the zeros are the same thing, except it's the opposite sign. So if we look at our first parabola, we have -4 and +2, but our zeros are -2 and +4, so the signs have just changed. And if we look at the next one, we have -7 and -1 in the brackets, but the zeros are 1 and 7. Now this connection of just changing the sign is only if it were a simple trinomial when you had factored it. If there had been a coefficient in front of x, then you're actually just solving the quadratic equation, because notice the y coordinates are 0. So if you set the y equal to 0, then you have a quadratic equation, and we know to solve a quadratic equation, we factor and then we branch out. So your zeros are the solutions to your quadratic equation. So I'm going to go down and make a little note of that. Zeros are the solution when y equals 0. And the shortcut is that it's the numbers in the brackets but the opposite sign. So opposite sign of numbers in bracket. So those are the zeros. Now let's look at vertex, and that probably comes from vertex form. So if we look at our vertex for the first parabola, it's 1, -9. I see the -9 outside the bracket, so that's great. And if I look at the x coordinate, my vertex is 1, but inside the bracket it's -1. So we're always just taking the opposite sign. So here it says -4, so my vertex is +4, and then -18 for the constant. For the last one, it says +4, but our vertex is -4, and then 12 for the constant. And then once you have the vertex, you have no problem getting your axis of symmetry, because notice your axis of symmetry is always the x coordinate, and your optimal value is always the y coordinate. So let's make a note of that. So here, the vertex is, so in our vertex form, you see you have a x minus h squared plus k. The vertex is the h and k. And notice I didn't write -h, I wrote h because I'm taking the opposite sign. So maybe you want to make a little note here about the opposite sign. Okay, now the next thing I want to look at is the direction of opening and the step pattern. If you notice, the first two parabolas opened up and the last one opened down. And what was really different here is this value at the start, and that is our a value. Here, the a value was +1. Here, it's +2. Here, it's -3. That negative makes the parabola open down. So let's make a note about that. And you'll notice that all of these forms have an a value. So the a value in front of x squared, the a value in front of your bracket, and same with vertex form. So let's make a little note here. When a is greater than 0, so when it's positive, your parabola opens up. When a is less than 0, so it's negative, your parabola opens down. And that applies to all three forms. And finally, the step pattern is the last connection I want to take. So if you remember, in that basic parabola, y equals x squared, this 1, 3, 5 was the basic step pattern. Now let's look at our a value. In the second parabola, the a value is 2, and my step pattern is 2, 6, 10. It looks like I just took this 1, 3, 5 and doubled everything. 1 times 2 is 2, 3 times 2 is 6, 5 times 2 is 10. Okay, let's see if it works for the next one. For the last parabola, our a value is this -3. So let's see, 1 times -3 is -3. 3 times -3 is -9. 5 times -3 is -15. So your a value, we can use it and apply it to the original step pattern to get the step pattern of our parabola. And that's going to be really important for when we start graphing. But for now, it's just a nice little connection. So I'm going to make a note. So our original step pattern, I'm just going to write SP for step pattern, is 1, 3, 5. The new step pattern is going to be your a value times 1, 3, 5. And there we go. Now, let's try to take these properties and apply them to a few parabolas. So once again, standard form gives you your y-intercept, the constant. Factored form gives you your zeros. It is the solution to the equation. And vertex form obviously gives you the vertex. Just make sure you remember that in the bracket we take the opposite sign. So anything with brackets, you take the opposite sign. And when we get to transformations and graphing, you'll see why we're taking that opposite sign. Okay, let's get started. So here is our first example. We have 3 equations for the exact same parabola. Does the parabola open up or down? I look at my a value, which is -4. That means my parabola opens down. And if my parabola opens down, so it looks something like this, then my parabola is going to have a maximum value. Okay, so I needed a little visual there. The y-intercept I know comes from standard form. And it's the constant, and the constant is +60. So the y-intercept is 0, 60. Now remember, a y-intercept or any value on the y-axis has an x-coordinate of 0. My step pattern, I use my a value, which I already know is -4. So I'm going to take -4 and multiply it by 1, 3, 5. So negative 4 times 1 is negative 4. Negative 4 times 3 is negative 12. Negative 4 times 5 is negative 20. There we go. Next we have our zeros. That's going to come from our factored form right here. So my first bracket says x minus 5. And I know the solution would be positive 5, the opposite sign. And the other bracket is x plus 3, which means my 0 should be negative 3. Okay, vertex form. I'm going to look at my vertex. And again, for the bracket, I'm going to take the opposite sign. It says x minus 1. My vertex will be positive 1. And then I take the constant on the outside for my optimal value, or the y coordinate. Okay, now that I know my vertex, I can get my axis of symmetry, because the axis of symmetry is the x coordinate. So x equals 1. And the optimal value is the y coordinate. So we have a maximum of 64. And if you weren't sure about that, there's no problem with drawing a little sketch. So my vertex is at 164. Let's say it's somewhere here. And my parabola is opening down. Okay, there's a parabola. Now I can see that's my axis of symmetry, so it must be the x coordinate, and 64 is the highest. So if you ever forget if the x coordinate goes with the axis of symmetry or the optimal value, always do a little sketch for yourself. Okay, let's try this next one. The parabola is going to open up because our a value is positive 2. And because our parabola opens up, that means it might look something like this, which means there is a minimum value. And now the y-intercept would be the constant in standard form. There's no number there, which means it's technically plus 0. So the y-intercept is 0, 0. Now for the step pattern, we're going to look at that a value again, and the a value is 2. So I'm going to double 135 to get 2 times 1 is 2, 2 times 3 is 6, 2 times 5 is 10. And there's the step pattern. Now for the zeros, we know it comes from factored form, which is right here. Now this factored form looks a little different because we don't have two brackets. Instead, we have x minus 8 as a bracket, and then 2x is kind of a common factor in front. Now, if we use the connection that the zeros are the solutions to the quadratic equation, you can kind of set your y equal to 0 and branch these out. And I know for x minus 8, if I set that bracket equal to 0, x equals 8, which is exactly how we would have stated the 0. But for the other one, if I set 2x equal to 0, I divide both sides by 2, and I get x equals 0. So my other x-intercept is at the origin. So there it is. 8 from here, and 0 from the common factor. And that's something you can just keep in mind from now on. If there's ever an x that has been common factored, it means that the x-intercept is at the origin. Next, we have our vertex, and that will come from our vertex form. So inside the bracket, it says x minus 4, so my vertex will be positive 4, and then negative 32 for the constant outside. And that means my axis of symmetry is positive 4, and the optimal value is negative 32. Now, I want you to try this third parabola on your own, so pause the video and try it out, and then come back to check your answer. Alright, so for the third one, our parabola should open up because the a value is positive, and because it's opening up, that means there's a minimum. The y-intercept is the constant, which is 0, 2 from standard form only. The step pattern, we're going to take that 1/2 and we're going to multiply it into 135. So you get 0.5, 1.5, and 2.5. The zeros are both going to be negative 2 because our two brackets in factored form are identical. And then for our vertex, there's technically a plus 0 at the end. So you have that bracket squared, and then the constant is 0. So the vertex is negative 2, 0, meaning the axis of symmetry is at x equals negative 2, and the optimal value is 0. Now, let's try one more little question here where I'm giving you the properties, and I want you to try to figure out the three equations on your own. So I have a y-intercept at 160, my step pattern is 4, the zeros are -10 and -4, and the vertex is -7, -36. Try this out. I recommend you start with your factored form and your vertex form because you have absolutely everything you need. And then for the y-intercept, there might be one value like either A, B, or C that you can't find, so try to problem solve through that. So pause the video and try it out, and then once you think you've gotten where you need to get or you're not sure where to go from there, come back and check your work. Okay, so I'm gonna start with my factored form. And for the factored form, I care about the zeros and the step pattern. This step pattern of 4, 12, 20 tells me that the A value is 4. So right now I know my equation will start with y equals 4. And then if my first zero is -10, that means the bracket must have been x plus 10. Remember the opposite sign. And then if the second zero is -4, then I should have x plus 4. So factored form, done. Vertex form, it's still the same A value, so I still care about that 4. So I'll start y equals 4, and then I know the -7 is going to go in the bracket, but it's the opposite sign. So x plus 7, and the bracket is squared, and then -36 at the end. Okay, so these two hopefully are okay. There was nothing really fancy we had to do. Now, for this y-intercept of 60, that means I'm going to go to standard form and I'm going to write plus 160 at the end. I also still know that the A value is 4, so my equation will start with 4x squared. But I don't know this part. I don't know what x I'm adding because I'm missing it. So right now, I don't know what b is equal to, how many x's I'm adding. But that's not a problem. If we can just take either our factored or vertex form and expand it, we can actually get the full standard form. So I'm going to go ahead and do that right here. So I'm going to do some FOIL to do my distribution. So x squared plus 4x plus 10x plus 40. I'm going to collect my like terms first so that I have 14 x's. And then I'm going to distribute the 4 in to finish this off. So I have 4x squared, 56x plus 160. And I know I've done it right because I see that y-intercept that the question told me about. So there we are. This is my standard form now. And that's it. Those are our properties. So standard form gives us our y-intercept, factored form gives us our zeros, and vertex form gives us the vertex. And all three of those forms can tell you the direction of opening and the step pattern.